that out of my system. Let's get started. We are working on 6.1 still, and we're working on arc length in area of sector. And I want to put these two guys here because some of the questions you need the answer to be in radians, or at least you need radians to get the answer. And in other questions, they want the answer in degrees. So if you want to turn degrees into radians, it's the degrees over 180 in pi, and leave the answer as 4/7 pi, whatever you get. Don't make it a decimal. And if you want to do the other conversion, how to convert radians to degrees, we're going to use this one. So bear in mind that when a question tells you something, that you have to be careful. Do they want the answer in radians or do they want it in degrees, and so on? So I'm just randomly picking a question, number 3 here. You got a circle, you got this guy, you know this is 3. You know this distance here, because they tell you in the picture, is 7. And we're being asked to find, yeah. Now that's not that difficult to do, because the arc length is r times theta. So you always start an arc length question with this. And that's 7, and that's 3, and this is theta. And so the answer would be 7/3. And when you use this formula and you don't do anything to it, the answer is 7/3 radians. Right? Pretty straightforward. Sometimes they don't want the answer in radians. They want the answer in degrees, and you won't even know it's in degrees unless they put a little box with the little, the little degree symbol. Now, if they do that, if you type this in, they will tell you you're wrong, because what you've done is given the answer as 7/3 radians, and they want to know it's degrees. So that's where you would move over to here, and you'd say, okay, how do I get degrees? Well, I get degrees by doing this fella. So on my calculator, I'd go brackets 7/3, that's that bit, times it by 180, and then divided by, where we go, divided by pi, right? And round off the answer, let's say to 1 decimal place. So watch out for that. Sometimes, probably most of the time, they'll want 7/3. But if they want the answer in degrees, you better do it in degrees, right? So you need to know how to convert when that happens. Does that seem reasonable? Just be careful, right? Now, if we move on and do something a little bit different, this is question 6. They don't give you a picture, but they tell you the center angle is called theta. They tell me the radius is 4, and that the arc length is 5. And they want us to find theta, but there are 2 questions. One of them says theta equals that way, and one of them says theta equals that way. You see, they're getting you to do both answers, right? Both versions of the same answer. Now, the calculation is pretty straightforward. Since it's an arc length, start with that. Put in 5, put in 4, put in theta, divide both sides, and you've got that guy. So this answer belongs here, right? That's the radian answer. Now, how do I get the degree answer? Pretty much you do this guy. You want degrees, it's radians, 5/4, divided by pi, times 180. Now I'm going to do 2 versions of that calculation. So first one, I'm going to go and I'm going to do 5 divided by 4 times 180 divided by pi. I get the answer. And the other one I'm going to do is 5/4 times, I think I know what's going to happen here, divided by pi. And I got the same answer. Okay. Bad question. Both answers are the same. What I was hoping to get, but it never happened in this question, is doesn't sometimes order of calculation matter? In other words, you need brackets around some questions. So we're good. That's the answer. Let me show you an example of that happening by picking a question which I do know that the order will be important. Suppose I'm doing a calculation and it ends up being 7/5, right, divided by pi over 3, right? Let's suppose I had that question. And I want the answer to be in as a decimal, right? Now, if I just type it in as 7 divided by 5 divided by pi divided by 3, should I do it like that? Do you see the order of calculation can make a difference? So here's my advice to you. If you're doing a complicated calculation, one that's got a lot of multiplying and dividing going on, it's a good idea to stick brackets around anything and everything you think might be a problem. Now, half the time, it won't matter. The answer ends up being the same whether you put brackets in or not. But the other half of the time, can't it make a big difference? Okay, so that's just a little hiccup that can happen. Let's move on then. Here's a question where the information is not really in the way I want it to be. We're being asked to find the radius. We're being told the arc length is 20 centimeters. And we're being told the angle is 50 degrees. And they ask us to round the answer off to 2 decimal places when we're finished, right? So we're going to find R to 2 decimal places. So I'm going to start with that guy. 20 is going to go here. R, I don't know. And now I have theta. Do I put 50 in here? No. Do you notice it's 50 degrees? So don't I have to do one of my conversions? And I'm going to take in radians, right? And in radians, it's the degrees, 180 pi. In this case, it's going to be 50, 180. Now, since they want the answer to 2 decimal places, I'm not going to turn that into a fraction, which is what I would typically do. Since they want the answer is in 2 decimal places, there's no point in doing that extra work. So here is 50 times pi divided by 180. And the answer is 0.87. And you might think, that's it. They want 2 decimal places, so I only need this to 2. Don't. Whenever you are doing a calculation that says round off the final answer to 2 decimal places, will you make sure that all the in-between numbers are more accurate than 2 decimal places? And the reason for that is if I did this to 2 decimal places, the final answer that I get will be different than if I use this. This will get me a better answer. And you know, WebAssign's fussy. Suppose the right answer was 1.2 or 1.23, right? And you got 1.21, right? You're only 0.02 out. Won't WebAssign say you're wrong because it wasn't 1.23? And the reason for that was that you rounded off here. So the rule of the game is, if they want you to do something to say 3 decimal places, do all your other calculations to at least 5 and only round off the final answer to 3 decimal places. So in this question, we are now going to be multiplying by 0.8726 radians, okay? Now, don't make this difficult. What should I do to find R?
By 20 by the
Horrible decimal. Okay. And on my calculator then, 20 divided by the horrible decimal. I get that, and that guy I'm now going to round off to 2 decimal places. Right. Now let me just show you the same calculation if I'd done just 87. So it'd still be 20, but I'm only going to divide it by 0.87. Can you see that that answer rounds off to 22.99? And if you type 22.99 into the Web of Science, isn't there a great chance Web of Science is going to say you're wrong? Right. So have I convinced you to be more accurate with your calculations and why you need to be, right? So apart from that, that's the answer.
Perfect.
Question?
Yeah, I was wondering why there's a difference when you calculate it. So instead of using the decimal there, if you were to divide 20 by 50 pi over 180,
you would get an even more accurate answer.
Well, yeah, but why is there a difference in dividing it by 50 and then shifting, or 50 pi and shifting the 180 to the numerator? Why doesn't it work the way that real numbers or whole numbers do?
I'm wondering what you're
saying.
What
I'm talking about?
Right, so here is that version, right? So if I was doing that, it would be what, 50 times pi divided by 180, right? That's how I would interpret that. So how are you thinking? Are you thinking?
No, so
50, you thinking of that and then a pi?
No. So dividing the arc length by theta, whenever I divide a fraction by a fraction, I'll just
oh, okay.
Yeah.
I got you now, right? Let me show you what you just did, or what I believe you are saying, right? You got this guy. And we know this is 20. We're going to do R, and right now I'm going to write in the guy that we had, and we'll put in the line just so that other people can see what you're saying. So what you would do is you divide by this fella. If I'm picking you up correctly, isn't that the same as multiplying by its reciprocal, which would be that? Great. Is that what you're getting at? Okay. Now, let's do that calculation and show you that it works. I multiply in brackets the 20 times 180, and I divide, and I put that in a bracket, 50 pi. See, it's the same answer. So you could actually do it that way if you wanted. Wouldn't you get the exact same answer, 22.9?
That's so bizarre. I don't know. Maybe it's something to do with the settings on mine, because yesterday for every question, it wasn't working.
Well, here's the thing. Did you remember to put a bracket around the two top guys divided by a bracket around the two bottom guys?
Yeah, I don't know if you can see, but it comes out to two different numbers. If you can see the...
Not real. I can see a 24, but neither of those numbers look like 22.9, do they?
Well, no, this is from...
Oh, a different question.
Yeah.
I wish we were in class, then I could just look at it. It's an idiosyncrasy of your calculator, perhaps.
Yeah, because it was off by over 100.
Whoa, that's a lot to be off by.
Yeah, okay, never mind.
Then next and final part, we're now going to look at questions involving the area of a sector. Here I get to try and draw a circle again, which is kind of hit and miss with me. That's not bad for me. It's slightly egg-shaped, but it'll do. Right, so there's the center. Here is the radius R. That piece of cheese, piece of cake shape is called a sector. let's say the angle subtended at the center, I think that's a fancy word for it, but the angle in the middle is theta. To find the area of a sector A, it's 1/2 r squared theta. And you can go in and watch videos to prove it to you, but it's connected to, isn't a full circle pi r squared? Right. The area of a complete circle is pi r squared, right? Kind of comes from that. So we are now going to find the area of a sector using this formula. Theta, again, is in radians. I'll start with the first one, a pretty simple one. Let's suppose I want the area of that sector where the angle subtended in the middle is 1/4 pi and the radius is 10. Then the formula is kind of designed to use these two numbers. So the area is 1/2 10 squared times pi upon 4. And that's 100, and half of 100 is 50. So I guess you get 50 pi over 4. And if you want the exact value, you tidy that up and you get that. Or if you want the answer as a decimal, can you just start, you could do it there in fact, but I'm going to do it here. You would just go 50 pi divided by 4, and you could write down the answer at least to one decimal place. The answer would be 39.3. And if the units were centimeters, since it's an area, it would be square centimeters. Would you agree that's not the ugliest formula in the world, right? It's just 1/2 the radius of the circle times the angle in the center. And that will get you the area of this piece of pie. Are we good? Any questions about that? Assuming okay. Let's suppose we give you a question that looks like number 9. That angle there is going to be 67 degrees, and the radius is 6, sorry. And we are going to find area.
Is that supposed to be in the center of the circle?
Are you complaining about my diagrams already? Yes, it's meant to be the center of that circle. I'm just not very good at picking centers. God, everybody's a critic nowadays. Here we go. Area is 1/2. If you think that's bad, you should see some of my circles. They look like eggs. I know you're not allowed to say, is that a circle that you've just drawn? Because, well, I can't do it anymore because they don't let me, but I will throw something at you. But evidently my boss says in America, you're not allowed to throw things at your students because whatever the rule is. So I'm not allowed to anymore. Could do it back in Scotland. You could throw anything at them, you were allowed, but that was then. Okay, so it's going to be 1/2 times 6 squared. Uh-oh, I almost did it because someone criticized my circle. I was about to write 67 then, wasn't I? But that's not the angle, is it? At least not in the form we need it. Aren't we going to have to convert it to radians? Okay. Now, I'm going to try some and see if it works. 67 pi over 180. Haven't I just written down what the calculation would be to turn that into radians? Now, you can do it this way. I've just decided to show you in another format. You can do it this way, or you can find out what it is as a decimal and write the decimal here. Your answer is going to be given to, you know, whatever. Does they ask you for any particular accuracy? Oh, I'm glad I looked. This answer didn't want the answer to 2 decimal places. They wanted the exact value, which means I need to keep it like that. Right? If I turn that into a decimal, there aren't decimals rounding off, because you have to round off somewhere, right? You don't get, you know, 3 decimal places. So we are going to have to figure out how to make this guy work. So I'm going to do it like this. It's a half times 36 times 67 over 180 pi. So what I've done is I've taken all the bits that are numbers and separated the pi. So that guy on the left, right, this guy here, that's the guy I'm going to do the calculation and then tag a pi on at the end. Okay. Not sure whether I need a half with a bracket in it, but I'm doing it anyway. I'm then going to do times 36, then times, I don't know if I need a bracket for 67 over 180, but I'm playing safe and putting a bracket around it. So haven't I basically did a half times 36 times this guy. Now I'm going to get a decimal. There we go. Then I hit math button, choice number 1, and it will turn my answer into a fraction. And the exact value for this area is 67 tenths pi. Let me, it's correct. I did it right. Now, if the question had said, I don't know, to 2 decimal places, right? Couldn't I have turned that into a decimal and then just did a big multiplication? Couldn't I do this guy and then find out what this guy is as a decimal? So I'm going to do that with this in front of me. So I'm going to go back to the original question, and I'll basically, all I need to do then is go 67 times pi divided by 10. And if that's what they were looking for, to 2 decimal places, the answer would be 21.05. So how do I know that they want an exact value, and how do I know when they want a decimal, right? If they want a decimal, the question will have to say, give me the answer to 2 decimal places, right? It'll have a 2 decimal places kind of bit to it, right? If they don't mention anything about accuracy, then you will assume that they want the exact value. Got that? So if they say to 2 decimal places, you know you're going to do this. If they don't mention it at all, they just say find the area, and that's it. You know that it's an exact value. How are we doing so far? Are we good? Right. Let's pick another one. Ooh. No, that was too easy. I like this one. Suppose I tell you that the area of the circle, the area of the sector is 20 square centimeters. And I tell you that the radius is 4 centimeters. And I ask you to find theta. And I want the answer to be in radians. Okay. You begin with the area of a sector formula, right? You know how we always begin with S equals R theta when we do those questions? We always begin with this formula. And now I'm going to put 20 in here. It's going to be 1/2 times 4 squared times theta. Okay, first time we've seen this situation. Anybody want to tell me what you think should happen next?
Well, you could do 14 squared, which is 16, and then divide that by 2, which is 8, and then divide that over, so it'd be 20 over 8.
Does that make sense to everyone? Basically, solve for theta, right? And we're using as long as you do it to both sides, okay rule. So basically you get the calculation and then divide. Oh, by the way, do you think that's going to be acceptable in WebAssign or anywhere? 28ths, does that look good?
5/2.
I think that WebAssign in that particular question will also allow 2.5, because isn't 2.5 an exact value for 5/2? But if the answer was a third, it's probably not a good idea to put 0.33 down, because won't WebAssign say, well, that's not really the answer, that's rounded off. That work good? Right, let's try a slightly different version in the same thing. I'm going to tell you the area is 100 square feet. And I'm going to tell you the angle is 60 degrees. And I'm going to ask you to find R. And I have deliberately put a sneaky bit in here. So A is 1/2 R squared theta. Nothing wrong with it. A is 100. It's a half times, we don't know, R squared. And nope, I am not going to put 60 in. That's a sneaky bit. 60 degrees, right? Isn't that another one of those convert me into radian, guys? Great. And 60 degrees is 60 over 180 pi, which becomes 1/3 pi. That's one of the ones you could actually get the answer in the unit circle. And I think that's a reasonable one to leave, because we're going to assume that this wants the answer as an exact value. So they don't want 1.23, they want an exact value, which means you can't find decimals for anybody, right? You have to work with what you've got. Eventually, I'm going to find R, but before I do that, shouldn't I tidy some things up? I have a half and a 1/3 pi. If you take a half and you multiply it by 1/3 pi, are we comfortable with a 1/6 pi, little bracket for emphasis, R squared? Are you comfortable with that? Okay, now tell me what to do next to both sides.
Divide by the radians and take the square root.
Okay, so you probably don't need this line, but I'm putting it in anyway. Do you know 1/6 pi? I'm going to write it as pi over 6. And isn't that the same thing as multiplying by 6 over pi? Are you comfortable with, you know, I'm putting every line that you could possibly want. And won't that become Are we good so far? Right, now, what do I need to do to both sides to get the exact value for R?
Square root.
And since radius is a positive thing, I think WebAssign will probably accept that. It's an ugly question, so they probably would accept that. If you were being a bit of a perfectionist, couldn't you split it as 600 over the square root of pi and make that 10 times root 6 over root pi, and then make that 10 times 6 over pi R? Would you agree that there's not an awful lot of benefit to doing what I just did? Because would you agree that's just as ugly looking as that one? And normally when you simplify things, shouldn't they look nicer than they started, not worse than they started? So I'd be totally happy with that as an answer. Now, if they wanted the answer to 2 decimal places, well, I've already got everything I need. Can't I just do the square root of 600 divided by pi? And to 2 decimal places, what? 13.82. So if they want it to decimals, you got it. If you want an exact value, you got it. Some people always get the exact value, and then they turn it into a decimal if that's what you wanted, or they leave it like that if that's what they wanted. Other people prefer to turn all of these things into decimals, and then it's calculated all the way. And as long as you do a lot more accuracy than you're asked for, you'll be fine. Right? So if they want 2 decimal places, do all the in-between stuff to 3 or 4, and you'll be fine at the end. Any questions? Is this going pretty good? Okay. No, done one like that. I'm trying to find something a little bit different. Okay, let's try this one. It's not that different, but it's a little different. This is 13. In this question, you're told that the area is 17 square meters. And you're told that the angle is that. And we're being asked to find R. And it says round off your answer to 1 decimal place. Okay, so there's the clue that we don't need to worry about an exact value. So A is equal to 1/2 R squared. There. 17 1/2 R squared times that guy. I'm just going to turn this into a decimal. Since they want it to 1 decimal place, that's fine. So what have I got? I've got 1/2, put brackets around it for safety, times 3 pi over 11. So there's 3 pi divided by 11, also in some brackets. And since they want it to 1 decimal place, I'm going to round this off to 3. Now I can get R squared by dividing both sides by 0.428. So 17 divided by 0.428. And I get the answer to be 39.7, actually 20 if you round it off to 3 decimal places. And then I can just take the square root of the answer, which is that guy. But to 1 decimal place, it's 6.3. And the good news is I'm right, because I can see the answer here. So do you notice what I did there is they wanted it to 1, but I did it to 3, just to be safe. If I did it to 2, yeah, I'd probably get the same answer. I'd probably end up with 6.3. But sometimes if you're really unlucky, don't you end up with 6.4, just the way the rounding up works. And you don't want to, you don't want WebAssign to be fussy, and you did it right, and because you were 0.1 out, that you think you've done the whole thing wrong. Okay, next one, question 15. Oh, I'll pause on that one. Can you remember yesterday we did the bicyclist story? Remember that one? Question 15 is the bicyclist story. Right? I'll do it again because there's a lot in it. They tell you, oh, by the way, there you go. That's a car. The car's wheel, right? Where is that guy that's going to complain? Tony, you are not complaining. That is a car. Agreed? Poor guy's frightened to answer now, right? So the single wheel of a tire has a diameter of 24 inches. And it revolves, so it does revolutions. It does 10,000 revolutions. And they want to know what's the distance that it traveled. Now, I know the arc length for one revolution, and it is r times theta, right? Now, for one revolution of a circle, theta is 2 pi. And the radius, the first part of the puzzle to catch me out. What is the radius of this circle, the wheel? It's not 24.
The 12.
Yeah, that sneaky little. And then, unfortunately, the number 24 appears in the answer, but it's for a totally different reason, right? Okay, we go with that. One revolution. Now, if you do 10,000, so the wheel turns 10,000 times, 10,000 revolutions, it's going to be 10,000 times 24 pi. And at this point, time for the calculator. 10,000 times 24 pi. And this answer is 753,982. And they want the answer to 2 decimal places. So I'm going to do that guy to 4, right? Just to be safe. And that was inches. So that's essentially the distance. Well, that's great if they wanted the answer in inches, but they don't. They want the answer to be in miles. And I think it was Katie, but it might be someone else. Can you remember what you need to do then to convert this distance into miles?
Oh yeah, you make it into feet, so you divide it by 12.
Okay, so we divide it by 12. And so since it's in the calculator, I'll just go divided by 12, which now gives me 62831.8531, and that's feet. And then you divide by
5,280.
Aren't these just weird numbers that you just have to remember when you're in America, right? So we got that number already in my calculator, so I could just go 5,280, and that answer is wrong. No, it's right. Okay, good. Whew, heart attack there. That answer is 11.90 when you round it off to 2 decimal places, and it is miles.